Hey there, man, Alejandro, and welcome back for day 235, me doing Daily LeetCode challenge that I reach 1 year's worth of great contributions here on GitHub. So today's problem is for March 8th, 2025, and without further ado, let's get straight into it. Okay, today we get LeetCode Easy, problem 2379, minimum recolors to get k consecutive black blocks. Okay, you're given a zero index string blocks of length n, where blocks of I is either W or B, representing the color of the ith block. The characters W and B denote the colors white and black respectively. You are given an integer k, which is the desired number of consecutive black blocks. In one operation, you can recolor a white block such that it becomes a black block. Okay. Return the minimum number of operations needed such that there is at least one occurrence of k consecutive black blocks. Okay. So essentially what I need to do, I need to get count of whites, count of blacks, count of whites, count of blacks, count of whites, count of blacks, and so on. This is an easy problem. Is it easy because of the constraints? I see. N is 100, right? If it was, if you had to do this in linear time, I think this was actually a problem that was similar to one of them that was on the weekly LeetCode contest, in one of the earlier ones actually. Okay, yeah, 60%. Yeah, if N is going to be small like this isn't actually going to be too bad, right? Because here we can say white comma black is equal to W and B. Prev color is equal to white. Color counts. Color counts is equal to this. I is equal to 0. For block and blocks. If block is equal to prev block, for color and blocks, if color is equal to prev color, then what will we say? We'll say cur count is equal to 0, cur count plus or equal to 1, continue. Else, color counts dot append cur count equals 0, color equals color. Cur count greater than 0. That append cur count. F string color counts equals. Okay. So this should be one white block. Uh-oh. Maybe cur count is equal to 1. Yeah, 1, 2, 2, 2, 1, 1, 1. Beautiful. Okay, here it's going to be 1 white, 1 black, 1 white, 3 blacks, 1 white. Yeah, this is cur count is equal to 1 because here we're resetting it. Well, now there's one color ball when we get to the next one. Yeah, makes sense. Okay. Yeah. Okay. All right. Yeah, we don't need a continue statement there. Different colors. Swap colors. There we go. Cool. All right, now the trick is white blocks are at even indices, black blocks at odd indices. Because the thing is, like, you know, I have to think of this as like a price of 1. If I pay this price of 1, then boom, all these become black blocks. But I might have to do this multiple times. So I'm trying to think, like, what is the right data structure or so on to essentially go about this problem. Yeah, this is kind of not immediately. It might be easy to brute force, and that's why it's an easy. But otherwise, in terms of a problem where you don't want to be, like, you know, too unreasonably inefficient, kind of a tricky one to think about. As every little thing is gonna be alright. Maybe it's easy in the sense that I can consolidate it all. Yeah, because I'm trying to think of this in a way to do it in DP, but yeah, this is not simple. Every little thing is gonna be alright. Don't worry about a thing. Yeah, because yeah, I don't know if there's a greedy way of doing this. Is there a? Yeah, it is a minimization. It is an optimization problem. So I'm probably right on track thinking of this in terms of a DP, greedy, or divide and conquer problem. It is an optimization problem for sure. Yeah, this was exactly the same as something I had in one of my daily LeetCode contests, but I forgot how to solve this type of problem. It's not an easy one either. Oh, my mouse is dead. What's wrong with my mouse? Uh-oh. Is my mouse dead? No. There we go. It should be revived any second now. Wow. My mouse, I've had this since I was 13 years old. Don't die on me. Don't die on me. Okay. Really? Wow, I need to hold it up? It's getting old. There you go. Okay, there we go. Okay, nice. Yeah, I just know because it's like rainbow colored whenever I have it on, which is kind of a nice tell. But yeah, alright, mouse is getting a little old. Yeah, this is not the easiest problem in the world. There's surely a way to solve this quickly, right? So you go up to a point, you decide. Yeah, I can do this based off. Here we'll do self.color counts is equal to color counts. So, def dp self and xi. No, but then I have to do 0. Gonna be alright. Baby, don't worry about a thing. Elf equals box of 0. No, I should make it like, you know, a standard color to begin with, no matter what, so that it's consistent across all problems. Every little thing gonna be alright. Baby, don't worry about a thing. 'Cause every little thing is gonna be alright. And for the black blocks. Also, yeah, you might not even be forced to connect stuff. But I mean, you can always pretend that there's 0 black blocks on the edges. So maybe we waste our wet blank. Maybe don't worry about a thing, 'cause every little thing is gonna be alright. Yeah, this is gonna be tricky in terms of how I want to do this. It's gonna be one of the hardest easies I've ever solved. Yeah, this is not a trivial problem at all. It feels like it should be, like, you know, there's going to be some trick, like some sliding window thing, some greedy thing, some DP thing, something. It's just not immediately obvious to me. Okay. Yeah, not immediately obvious, eh? What can we do? So we have the number of white balls, black balls, white balls, black balls, white balls, black balls. Might take the max. Like, I don't know if I can always say, like, right? Like, what if I have, like, you know, like, what if I have 0 white, 5 black, 1 white, 5 black, 99 whites, 8 blacks, 99 whites, right? If this is the max, right, and k is equal to 10, or even 11, right? Then it's like here it'll take 3 of here, 3 of here to make it 11 blacks. But here I replace this to a black ball, and phew, you've got this, right? And this only took 1 operation, and none of these were the max. But it could also be that, like, you know, this happens to be a 10 and so on. So there's multiple cases. Yeah, this is not an easy problem. So you can't use a heap really for something like this. Baby, don't worry about a thing, 'cause every little thing gonna be alright. Baby, don't worry about a thing, 'cause every little thing gonna be alright. Yeah, wow, this is a hard easy. Return the minimum number of operations needed such that there is at least 1 occurrence. Why is this so mentally tough for me? Consecutivo. I guess it's like, you know, maybe you look at, like, you know, the first however many white balls, and if you're not gonna set any of them, then it's like move on, right? I could do 2 DDP. Baby, don't worry. Black. Count. Okay. Elf. Black. Self.k. Turn 0 if I greater equal to self.color counts. Return float of infinity. We're gonna put a cache Yeah, I can solve this in a brute force way. Maybe that's like how you're expected to do things, right? Because it's an easy after all. Return self.depends 0 and a little black. Num_white is equal to self.color counts and xi. Max white black count num white in range num white +1. I will do this as 0 case too. We'll do was float of infinity was min of res as well as self.dp. Will be what, I+2 for the next white. If choose num white balls can connect with black next set of black balls. I+2. No, not I+2. What am I doing? What am I doing? No. This is dumb. Bi. Well, we're currently at a white. It's white, black, white, black. We're currently at whites. Yeah, num white is equal to this value. Case 1. Balls on left to complete problem. Case 2. Bother adding any balls. Case 3. Balls connect with next. something like that. Case 2, case 3. That's probably not correct, right? Black. No, I didn't mean to submit. Okay, I just wanted to run. Yep. Set okay. Okay. The evens are, yeah. That's odd. If it's odd, that means it ends with a white. If it's even, that means it ends with a black. Color counts that append 0. That's not enough. Unless I'm doing it wrong here, but I doubt that's the case. Yeah. And a white at the end. Count 0. We'll say black count and self dot memo returns self dot memo of I black count. Here we'll say it's equal to that, return it. This res equals this, print f string self dot memo equals return res. White black, white black. This should be self dot next black count equals next black block. This. Something like that. Okay, so it's accepted in these two cases. Is it accepted generally? No. 118 out of 122 is crazily close, though. Holy crap. We're on to something for sure. Maybe it could be something like as easy as that. Or something as easy as this. No. type out manually. Okay. This equals true. I don't know. Dang, 118 out of 122 though, that is really, really close. That doesn't help it. Interesting. Is this correct? If num white plus black counts, then yeah, just add the difference. Black count is greater or equal to k. Return 0. Beautiful. I mean, otherwise what we can do is case 4 in between. Res equals min of case 1, case 2, case 3. For white count in range 1, num white, then we'll do equals self yeah, 0 plus just next black block. Yeah, you won't have 0 as white. Something like this is not sufficient, right? Yeah, okay. Just making sure. And this one starts with a black specifically. Because every little thing is gonna be alright. Baby, don't worry about a thing. Is equal to white counts equals to white count plus next black block. Was min of res in the case is equal to res return rails. Yeah, so obviously that works, but now my solution is going to be way slower. But there we go. Completion streak 235 days. Consistency is key. See ya tomorrow. So yeah, yeah, a little bit cheeky, but I basically did the case of like, you know what? If it's not going to be just no or all balls, let's do every single possible permutation possible on planet Earth, right? Well, yeah, there's obviously probably some way to do this way faster, just given that people are doing this in 0ms and I'm doing this in 52ms. But hey, since the input size is small, this is exactly what I said at the beginning of the video. You're going to be able to brute force this because it's an easy, but it'll be interesting to figure out how you're able to do this efficiently, right? The way that I did it is just nothing special. It's just like try every single possible case. It's very boring. But hey, it works. 'Cause every little thing gonna be alright. Baby, don't worry about a thing. 'Cause every little thing gonna be alright. Oh, now this is too slow. So it does need a cache, eh? I get it, I get it, I get it. You need a little bit of caching up in here. You need a little bit of caching. Hey, that makes it faster. Very cool. Very cool, really. No. This makes things faster, you say. Because every little thing gonna be alright. Alright, I believe you. I believe you. We'll get rid of this guy. We'll get rid of this guy. And we'll put in the cache checker. Ooh. This is also because I'm printing this. This could be a lot of my slowness happening here. It's because I have to print my entire memo. What I bet you is happening is that memo is indeed faster. What's not fast is printing it all. Yeah, exactly. Okay. 'Cause every little thing gonna be alright. Cause every little thing gonna be alright. Baby, don't worry about a thing. Else break? I don't know. Nope, not quite. This, if this, sort of infinity. Black, count. less than case 1. That's case 1. If res less than case 2, res equals case 2. If res less than case 3, res equals case 3. There we go. That's bloody sad, eh? Now, why would it be wrong now, eh? What? Literally, what is happening? Did I mess up the case 1 logic? No, this is fine. This mess it up? Oh my gosh, I'm actually dumb. I know the cause of all this. It's because I'm returning the max possible answer. New case less than res. Case 3 less than res. Or here we can make things a bit easier. If res greater, if res greater. If res greater. If res greater. Gonna be alright. 31 ms. Still very slow. Yeah, this I could really just bring it in the other one. For white count in range. Right? I could just do something like this. Yeah, but it is what happens pretty much. I mean, yeah, this is a slow solution, but it's a working solution, which is what is nice. And yeah, so what I think I will do is I will probably do, like, you know, my quick recap of how I solved the cell problem, and then we'll look at the editorial to figure out how this was done faster. So you know what? Let's drink a sip of water. And let's get ahead and do exactly that. Okay. So as always, in all my videos, I do a quick recap of how I solve the problem. So for this one, essentially, we're given a 0-index string blocks of length n, where each character is W for white ball. Is it? Yeah, it's blocks. Okay. W for a white block or B for a black block. Black block. This just reminds me of a joke that just goes like, you know, if I had a clock here, it's like, you know, a big black clock, right? And so that sounds awfully like that. So, you know, consecutive black blocks, and so it's hard to say that for me. But anyways, you're given an integer k, which is the desired number of consecutive black blocks. Yeah. So essentially, you want to have k consecutive black blocks. Okay. You're given a bunch of consecutive white blocks followed by consecutive black blocks, consecutive followed by white blocks, black blocks, white blocks, black blocks, etc. Right? So here it's like there's one white block, two blacks, two whites, two blacks, one white, one black, one white. Right? If anything, I'll call these balls. Right? It'll be easier for me to think of them to say balls and blocks, because black blocks is just it's like a tongue twister for me. So one white ball, two white balls, two black. Oh my, okay, that also sounds like now. Okay, I'm just being dirty minded now. Okay, so just one white block, two black blocks, two white blocks, two black blocks, one white block, one black block, one white block. There we go. And so that's kind of the sequence. So the very first thing that I do is essentially it's like, okay, how about we turn them into like actual numbers? So it's like, okay, I'll instead of having a whole string like this, I'll be like, there's one one white block, then two black blocks, then two white blocks, then two black blocks, and so on. And that's exactly what I do. So here, if I print f string my cur count or color count, I should say, what you'll see here is that's exactly what I have. Here I have 1, 2, 2, 2, 1, 1, 1. Why? Because, well, first of all, I always start with white blocks. And so here at the beginning it says, oh, I have one white block. It could be 0 white blocks if you're starting with black blocks, right? So here's like, I have one white block, so that's a 1. Then I have two black blocks, which is why I have a 2 here. Followed by two white blocks, which is why I have a 2 here. Two black blocks, which is why I have a 2 here. Then one white, one black, one white. One white, one black, one white. And so the even indices are the white blocks. The odd indices are the black blocks, right? And that is kind of the point. If you look something like case 3 over here, that starts with a black block, and so the very first value will be 0, denoting 0 white blocks at the very beginning. You always start with a white block for me, and then it'll be the even indices are the white blocks, odd indices are the black blocks, right? And that's kind of how I went about this problem. I did it in a very inefficient way, so I really want to check out what the editorial says once I'm done with my explanation, but first I'll explain how I solve this problem. And so that's basically the general setup that I get at the very beginning, and the way that I do it is like, okay, we'll always consider the previous color, and we'll keep adding, blocks to that, to the current, amount of blocks inside of my current group, starting with a white group, and it's like, okay, color counts is initially equal to an empty set. The current count of white blocks I have at the very beginning is 0, and then we'll say, okay, for every single color in blocks, as long as it's still white, I'm going to keep adding 1 to my cur count, right? If color is equal to previous color starting with white, then we're just going to keep augmenting cur count and continue, right? Otherwise, if we get to a point where color is not equal to the previous color, then we're swapping groups, right? We're switching from white to black or from black to white. So in this case, it's like, okay, append the number of blocks we currently had so far for our current color. Then we'll say, okay, now let's say we went from white to black. We'll now we just saw our first black block, so we have at least one black block right now. So our current count is equal to 1, and we're going to swap the previous color to the new color, which is color, right? And so I essentially keep doing this until I populate my full color counts. At the very end, if cur count is greater than 0, then I'll append that, because it's like, at the very end it could have been just appending the very last set of consecutive things. So I just append it. I might as well make this, well, this is guaranteed to not be 0, so if anything, I can just do handle last consecutive blocks as well, right? And so something like this should be just fine. And there we go. So that's essentially how I get that out of the way. Then essentially I say, okay, this color count, so we're going to make this global variable, as well as self.k, self.memo, and a self.dp. So the way that I solve this is with dynamic programming. Essentially I take an index I, which essentially represents the current group of blocks that I'm looking at, right? Now our color count is essentially like, how many whites do I have, followed by how many blacks, followed by how many whites, and so on. So it's like, index of this array, and then black count to essentially incorporate how many consecutive black blocks do I have currently at this moment, looking from this index I, right? Dang, my mouse is actually kind of broken. This is kind of sad. Okay, it might be over for that little mouse. No worries. Okay, so here it says, okay, classic DP. If this is my input. If it's already my self.memo, then return that, right? If I've already solved this problem before, then return to me the solution for this problem, right? Otherwise, k is equal to self.k. Okay, so first of all, if the current amount of black blocks that we currently have is greater or equal to k, then we finish the problem, right? Because here it's like minimum number of operations needed such that there's at least one occurrence of k consecutive black blocks. Well, in this case, since the amount of black blocks we have is greater or equal to k, beautiful, we just return 0. 0, there's no more operations that we need, right? And so here we're starting from index 0, and here we say, okay, 0 black blocks initially, because here we're starting with white blocks, right? That's kind of the idea. And then what we're going to do is like, okay, we're always going to look at an index that is white blocks, right? So here's like, we start at index 0, and index 0 is going to be white blocks. Even if there's 0 white blocks, remember, we're going to start off with the amount of white blocks at the very beginning. And so here we're going to say we currently have 0 black blocks, but what's going to go on is like, okay, we're going to look at the number of white blocks that are currently in our group right now, right? And then what we're going to say is like, okay, well, result, we initialize it to infinity because we want to minimize it, so we're going to look at the best case later on. This is just a placeholder value. So case 1 is, okay, can we keep just adding white balls right now until we solve the problem, basically, right? Really, I could just get rid of this because I don't need it. Really, there's only 2 cases, which is anything between 0 and num-white and this guy over here, but we'll leave it as is. If anything, yeah, you know what? To simplify my explanation, we're going to get rid of this over here. We're going to say, case 1, add all balls with next. Res is equal to 1. It's equal to this. 2 plus. That is not all the balls. Add all the balls. Zero to n minus 1. Okay, beautiful. So case 1 is like, okay, if we add all the white balls, then here's what's going to happen, right? So currently we are at a point like this in the array, right? We'll have a dot, dot, dot. Here we'll have another dot, dot, dot. And we currently have a number of white balls, right? It's going to be followed by a number of black balls, and followed by another number of white balls, followed by another number of black balls, and, etc., right? And so here we're currently looking at where this is our index I, right? This is our index I. Then here what I'm going to say is like, okay, well, if here I should probably put, B0. Okay, we'll just do things this way. Here, okay, yeah, B0. This is the number of black balls that we have, right? This is initially 0, right? Because since we're starting with with white balls, I should say we currently have 0 balls at 0 black balls at the very beginning. But like this is our current black count, right? And so here I'm going to say, okay, we have this white balls. If we fill in all the white balls here, then we will end up connecting these 2 groups over here, right? So that's very important. So if we add all the white balls in here, then what will happen is we'll continue on from index I plus 2, so 1, 2, we'll continue on from this guy over here, but every ball in here will now be black, meaning that there's this plus this many black balls, right? So it'll be B0, which is our black count, plus W1, which is the number of white balls, but this is also the price that we're paying, right? We're converting all the white balls inside of here into white balls, and then these will be connected to B1, so next black block. So it's like, for an index I, the next black block is an index I plus 1, and so this is exactly what we get. But we do it only if it's in balance, otherwise 0 next black blocks, right? And so this is our case 1, which is we fill in all the white balls in here, which will connect this group and this group together, right? Otherwise, if we do anything that is not all of W1 here, right, which I'm calling N, then essentially I will be ignoring all the black blocks that I have on my left here, and only considering adding white balls here that will be connected to this B1, and then moving on and capturing all these B1s and going on to this W2. But I will only be using the balls from W1 that will not connect with B0 because I'm not using all of them, right? So for anything between 0, right, because I could also choose to just not do any single white balls from W1. I could just ignore the whole thing if I wanted to, right? So from 0 to num white, then essentially I'm going to say, okay, this is going to be the white count, so anything between 0 and all of the balls in W1, except the case where it's all of them legitimately, so right, so up to range up to num white, but not inclusive, right? We'll do a new case where white count will be the price that we pay, and we'll go from index I plus 2 and white count plus the next black block. But notice we're not adding black count here because now we know it'll guaranteed not to connect these 2 pieces over here, right? And that is kind of pretty much it, right? There's just one case where it's like I add all the balls and then these two are connected, or I don't add all the balls and then I just keep on moving forward, right? Either way, I'm just doing a simple DP over here, and this is a nice and working solution. So this is what I meant by like, I can reduce the cases, because like, I had a case where it's like, oh, do I have enough white balls? Or, oh, do I do the case with 0 and so on? Really, the only case that matters is when I do all of them, because that changes things. Otherwise, they're all the same. So that's why I just captured it inside this for loop, right? And here we can submit. And I don't have a super efficient solution, right? We're at 23 ms, where some people are getting 0 ms over here. So I know there's a much faster way of doing this, which I want to check out, but at least this should explain how I was able to do this problem with very, very, very naive 2D dynamic programming, but taking advantage of the fact that this is an easy problem with very, very small constraints over here. So now that was pretty much it in terms of how I was able to solve the problem. So now I get to look at the editorial and see how this can be done more efficiently. So let's get started. Okay, a queue. Is that the only approach? Queue sliding window. I see. Okay. We're given the string blocks where each. Okay. Wait, what are the time complexities? Yeah, O of n. See, there's a faster way of doing this. O of n, O of 1. Ooh, very cool. Alright, Q. Since existing black blocks don't require colors, a required number of operations is determined by the number of white blocks. Oh, we must evaluate all segments of length k. Oh. There's no way. Wait. I don't even want to read anymore. I'm not even thinking of a Q solution right now. I'm strictly thinking, it's going to be, wait, I'm strictly thinking in terms of sliding window. Wait, this is so easy. There's a reason why this is a LeetCode easy. All right, sometimes easy does it, ladies and gentlemen. Okay, def, I'm just going to call this def overcomplicated, right? Return self.overcomplicated, overcomplicated with blocks, right? So this works. And k. I know what to do. This is so, I'm so dumb. I literally called, like, I was like, there's gonna be some sliding window, there's gonna be some this, or there's gonna be some either DP, whatever. I got hooked on the idea that this is an optimization problem, so I was like, oh, okay, it's probably gonna be greedy DP or so on. This is gonna be so obvious. Just take L is equal to 0 and do for is k greater less than or equal? Yeah, k is less than or equal to n. So here we can just do the same thing as before. White comma black is equal to W comma B, right? We will say L is equal to 0 in range K, num white count plus or equal to y equals white. In range K, length of blocks, we'll say plus or equal to blocks of R equals white count blocks of L equals 1, L plus or equal to 1. And here we'll say if white count less than res, or if res greater than white count, res equals white count. Return res. Oh my gosh. I'm actually so stupid. That's so obvious. That's really so obvious. Okay, I'm getting late. I'm getting sloppy with the LeetCode here. Okay, at least that's a. I don't. I didn't even think of just like looking at things in terms of of blocks of length k, mates. That's just completely slipped my mind. I guess I haven't done sliding window in a while. It's pretty much the thing. I'm losing the sharp the instinct side of LeetCode, and so I'm getting sloppy with my LeetCode solving capabilities. Damn, that feels pretty rough. That feels pretty rough. Not gonna lie. Then, okay, I mean, at least, yeah, I didn't even need to read, like, anything beyond this. And so as soon as it said, we must evaluate all segments of length k, I was like, nah, bro. Of course. Of course that's going to be faster because you can just sliding window your way through. Yeah, I don't even know what the Q solution is going to be about. But, okay, since this is O of n and I see some size time complexity is what? What's M? Okay. I don't know. It's probably the sliding window, but just like with more memory or so on. Yeah, that makes a lot more sense. Okay, you know what? How about this? As always, in all my videos, I do a quick recap if I was able to solve a problem. But this one, I looked at the editorial. I read up to just this point over here, and I realized, oh my goodness, there's a way more trivial way to solve this problem. I completely overcomplicated this. I've actually called my old code over here def overcomplicated. Now I have a much faster solution, and this is so obvious. I don't realize how I wasn't able to realize this right off the bat. But there's a way simpler way to solve this, which is just via sliding window. Here, essentially, what you do is what you have to consider is every single block of length k. That's it. And so every single length every single segment of length k, just have the number of white blocks in there, and that's how many you'd need to change to have that segment of length k be all black blocks, right? Since you're going to consider every single segment of length k, eventually you'll find which one would have been the correct one, and you'll know how many white blocks are in there, and that would have been the price you pay there. So you'll eventually end up finding the optimal solution. So here I just have my white and black variable set here. I'll start off with the very first k elements as the very first segment of length k inside of the array. So it's like, okay, L is equal to 0. I initially have 0 white balls. We're going to look at the very blocks. We're going to look at the very first k blocks, and we're going to append to our count of white blocks the total amount of blocks in the first k blocks that are white. So for each I in range k, we'll just add 1 if blocks of I is equal to white, otherwise 0. That way we have a white count. Here we'll initialize the rest of that, and then we'll keep on sliding window our way through, right? So for a right pointer in range from k all the way up to the length of blocks, we're just going to essentially add the block at index r, so remove the block at index l, right? So add the block at index r, so augment white count if the blocks at index r is equal to a white block, and subtract from the white count if the block at index l is a white block, right? Augment your left pointer as well, obviously, and then just update res every single time you find a better solution. So if res is greater than the current white count, then update res to be the current white count, right? That way res will be the smallest white count you've ever seen so far out of every single segment of length k inside of the entire array, or the entire string, I should say, which obviously makes this whole algorithm O of n, and there you go, bada bing, bada boom. You have a very nice and efficient working solution, and definitely much less convoluted and overcomplicated as my DP Palooza mess of a solution that I have over here. Yeah, I completely lost it with the instinct. For this problem over here, I didn't capiche what to do immediately, which means I'm getting rusty with my pattern recognition over here in LeetCode, which feels bad. That means I need to grind it out a little bit more. I've been lazy, not doing my contests and so on. We've been getting a streak of easies in the month of February and so on. I'm already starting to lose sharpness, even though I'm still doing the daily LeetCode every single day. So a little unfortunate, but yeah, obviously as soon as I realized just look at every segment of k, immediately got it. Okay, sliding window, super obvious, and makes sense why this is an easy problem. But yeah, that didn't come to me immediately. I immediately started thinking, it's okay, let's think of them as groups, and how can I solve the problem from then on, which is why I came up with a dynamic programming type of approach that just happens to be very, very slow. Definitely not O of n at all. But yeah, maybe it might be even a pseudo polynomial, right? Because it keep track of like black counts, which is at most I guess like the biggest. Actually, no, black count will be at most like they're all black or so on, whatever. So like you can think of this as an of n squared algorithm in the worst case, but still pretty bad, right? Or of n times k, just because like a black count is limited by k and so on. So not too bad, but yeah, still definitely not linear, right? That's kind of the point. Yeah, this algorithm is way crispier, way cleaner, way faster, way better, right? So the sliding window approach definitely a lot better, but I might as well just leave my overcomplicated solution here, just like as a recollection of my sloppiness for the rest of time to see, since I upload my solutions to GitHub every single time that I solve a LeetCode problem. Yeah, but nevertheless, without further ado, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So until then, ciao, ciao, my friend. Bye-bye.